Hello, good morning, good afternoon, good evening. Today, I want to speak about a database sharding. I think you know, I know, everybody knows in terms of database sharding. It's much of a discussion in terms of theory. You're splitting the database across DB instances. Uh, but today, we're going to talk about in practical how things has been done from a database sharding as well, how it is important also from a microservices. But before that, just a small introduction about me. So, I'm Shubhrata Roy. I'm working as an enterprise architect and the cloud architecture and app modernization phase. I have over 15 years of experience in designing and implementing strategic ID solution, strategic cloud adoption, driving data transformation. And my experience lies across various geographies. India, US, UK, Europe, South Africa, Singapore, and Middle East. Those are my key geographies which I worked. And I've also worked various industry such as banking, insurance, mortgages, and the manufacturing also as well as retail. And yeah, I'm a thought leader in emerging technologies and best practice implementation for technology transformation. While I come from a typical IT consulting background, and at the same time, I have looked to work into some of the strategic part also. System design is something important, which is very interesting to me right now. So, from the system design perspective, I kind of took a subject which is very relevant right now from a whenever we talk about an IT transformation, when you're designing and implementation. So, what are the things to key consideration? So that's what from system analysis this keep me interested, and that's what I talked about right now in the various subjects. So today's discussions on DB shardings or database shardings is also important. Now, before talking about DB database shardings for implementation, let's talk about the partitioning side. So we all know, right, what is partitioning in theory, right? So what has happened in the just to understand that what is the difference, right? So if I typically look at in the partitioning perspective, right? So partitioning, what happens that so there is a client, or there is a servers, or there is a end users, whatever. It is reaching to the DB, and suppose it is asking for a select name from the customer tables, and the where ID is suppose 7 dot dot ones or 00001s. It's so millions of records it is looking, and then it searches the DB in tables, and then it is finding that okay, now from a 70001 perspective the name is Roy. Now what has happened today? Your per second the hitting to the database server is today is suppose hundreds, and tomorrow it is going to increase. It may reach to a 1,000, 2,000. Definitely it will hit the performance. So from that perspective, you may first think about, let's do a split. Now, how do you do the split? Maybe you have 1 million, 2 billion records with respect to tables, and then you split into maybe 4 or 5 tables, and that tables keeping the same schema. That's called partitions, right? So you within the same schema, you are just keeping that within the same database, your tables, you are just making the partitions, right? So that's talk about talking about the partitioning perspective. Like, now partition can be happen horizontal as well as vertical. So horizontal is nothing but it is a range of list, and vertical is large columns that you can store in a slow access in its table space. Yeah, so I think so that is all about the partitioning. But if I look at the shardings, that's where there is some you can say understand the difference between the partitioning and then the sharding. So sharding happens that you are actually not uh, keeping your tables of in the same database instance. So you're creating more database instance, and within this instance, you are actually putting your tables, right? So if I look at that, from the previous example, we talk about 1 million rows, and you're just doing, small stable, and you're using the same instance you are keeping, right? The same schema. But here, sharding is different. You split millions of row into multiple DB in an instance. Suppose it may be three, it may be four, it may be five, based on your uh, requirement. So now, this is from a theoretical aspect. You talked about the what is the partitioning and what is the sharding. I understand that. Now, from a if you look at it today, the ecosystem design happening, and microservices is one of the major components, right? So, as I said, the in terms of uh, work in terms of that, hitting to that your database today, it may be, concurrency perspective, it's a 10, then it will go to 100, thousands, and millions. So if those things are, you know increasing, per millisecond or per second, uh, then you definitely need to think about how do you scale up, right? The scale up can happen that, you first do a partitioning, and second thing is that even partitioning is not helping. The second thing is that you're talking about the sharding. Now, sharding with the sharding, that is something called the vertical sharding actually. So it is again, you are distributing your tables across the multiple databases. Now think about uh, what is that you are distributing, right? So, for example, is that I'm giving one scenario, like you have a DB, one database, and then you have a tables, right? Table 2 1, table 2 2, table T3, and T4s. Now, when you do that shardings, what will happen? The vertical shardings, you are actually making more instances of DB. Now DB1, you can you can keep DT1, DB2, you can create the T4. It completely, based on the requirement and based on the, domain expert domain inputs. Like, hey, if it is e-commerce or if it is payment systems, where you need to keep, right? You need to think about, which is having the read access, write access, all those permutation combination you have to think about, right? And based on that, you can decide, right? So now what has happened that, DB1 you kept T1, maybe from access aspect or read access to a write access perspective, it is a two. It is require, in terms of CPU, in terms of your memory, this requirement is high, so you keep it a separate instance, right? And T4 you kept in DB2 and T34 where there's the lowest minimum heat, you are keeping it in DB3. Now, what has happened here? Definitely, you are, from a scaling aspect, you are trying to achieve the better load handling and the handle the larger volumes, larger scales. And this is what, from a Microsoft perspective, that vertical sharding is playing the key one steps. Now, important thing is, suppose it has happened that, for example, sudden changes happen, and it happened that there is so much access or so much hitting is happening in the T3 tables. Now, already the in terms of the infrastructure wise, the CPU memory utilization, it has reached up to, maybe 80%, and then it is showing some slowness, right? So what decision you can take? You can go definitely the horizontal part of it, and then, one more instance and all this. But there is other ways. That's what the vertical sharding came. Say, can you move the table to, T4? Why you want to say, hey, T4 is right now, it's very in stable positions, and then this instance is does not have any sort of hit, right? And then can you move that? So if you want to move that, how practically, what are the things you need to do, right? So this is what, the beauty of the vertical shardings. So what things you need to do? First, you have to consider the rules, right? The rule number one: whenever, today this db1, db2, db3, all those meta information like t1 is here, t4 is there, and t3, t4 is there. These sort of information, somewhere it has to be kept in, some central locations, Okay, so that whenever there is a API server is sitting, he knows, okay, I for a T1 tables I have to reach to DB1, or a T3 or T4 I have to reach the DB3, right? So those meta informations you need to keep it. And at the same time, suppose you want to move from T3 from a DB3 to DB2, and then you have to figure out, hey, I need to do some configuration changes. And at the same time, I need to update my API server. Hey, this T3 is located to DB2, right? So who will do this update? So that's the things you have to keep in mind. So that is what from a vertical shading aspect is important, right? In a practical scenario, I've been telling. So now you know the rules, right? One is that meta information, which needs to be kept, and if there is a certain movement is happening, those information also needs to be updated so that API service expected is known that okay, this table is going to be. So that's where there is some zookeeper tool actually become a very handy over here. So Zookeeper tool is from a uh, uh, I'm a typical all capturing all those meta information at the same time it is keeping all those updated to the API server. So whenever API there is some changes happen, API server it knows that where it is at. So how it works, if you look at, so you have a users, you have a suppose this is the API gateway and it's reaching to the API servers, and in general it is reaching to the DB1, DB2s, and certainly there is a table movement. Either the T2 is necessary to move to the T1 or T1 move to the necessary TB2, right? So what will happen? Whatever things are happening, zookeeper is always alerts updated, right? Uh, through this partitioning service. Say, hey, now for API server 1 and API server 2, for anything you want to reach specific to T1, you reach to DB1, and anything specific to T2, you reach to DB2. The moment there is some movement, Zookeeper will update, hey, right now T2 is not in DB2, T2 is in DB1. So you have to reach that. So table movement, configuration change, everything is handled by Zookeeper. So that's a from a shading vertical shading perspective, how it is working right now. So just wanted to say that how this movement is working, right? I mean, whatever talked about is all from a theoretical aspect. Okay, this is how it is work, but how do you do that movement, right? So there is a few steps which needs to follow, right? How you move from table one to another table, that is the steps. So first thing is that you look at scenario, T1, T2 is some database, then you are moving to the T1 to the other database. The first thing is that dump the table T1 along with the bin lock positions. Please note bin lock positions is important. So bin log, I think you can do the Google research also. You can find that what is that bin log position. So bin log is actually having all the information about that. If you are moving the particular table from this database to this database, it's having all the information. What are the operations has been considered. And when I say the dump the table T1 element, so for example, if I look at the MySQL database, right, it has that native features of MySQL dumps. So you looked into that. That is one of the example. And you looked into other database also. So MySQL dump is one of the example of when you say the dump. Now once you have done that, right, so certain thing is that first step, you dump the table from T1 along with the build languages. Second step is definitely I talked about the restore the dump to another DB. But before that, I think what you have to do is that upload the thing to the target DB that I have missed. Okay, what you will do? Upload the table to target DB. Okay. So once you done with the upload, and then the second step is restore the dump to another DB. So your restoration process will start. Number three steps, which is very important. So now, I think from operation aspect, the DB1 is still there. Table one is still there and it is working. But there is a difference, right? There is a changes which are happening in DB1, right? So you have restored in DB2, but that changes needs to be captured, right? That is what you can use the replication, right, from DB1 to DB2. Now, replications can happen with any of the database native tools, or you can may look at some other tools also. So again, using with the help of the tools, you have that replication. So DB1, try to do it, to capture so that what are the changes are there from the DB1 perspective. So all is been applied to your DB2. So once both are almost replicated, I will not say that is the 100%. It's not feasible. So both are almost replicated. Suppose there is slight difference. Then the certain things you have to do. You have to do that. I don't know the what exact language is. So I kind of say that it's a cutover from DB1 to DB2. Mm. So how do you do that? I think we spoke about the zookeeper. So what are the first thing? You rename the table. Earlier, if it is a T1, yeah, if it is replicated or changed to move to the DB2 and rename that DB2 tables and update the entry in a zookeeper, right? And what zookeeper will do? Zookeeper will update your, if I see that your API server, say, hey, T1 uh, has moved to T2 and it is renamed, all those things, configuration says it will update. Now, if anything is happening, if anything is required from AP servers from a T1 perspective, it will come to the DB2. So that's what I'm saying. So, rename and update the entry in the zookeeper. Now, while you are doing that changing of the table name and you are updating this, these are actually some manual things, right? Typical engineering stuff, right? So what will happen that for a few seconds, there will be a error, right? I mean, there is till now I didn't find that any sort of how to do that automated way. So there is no, but till there's a few seconds there will be some error which is showing that they will not found, but it's a very few. Now the fact is, here there is a two things from the studies and aspect. There is, I think, cap theorem. All you know. So here, I think from a importance is given the availability over uh, consistency. Sorry, I'm saying that consistency has been given the more importance with respect to availability. Now, availability, as I said, there is a few seconds there will be an error which is showing cabinet found, but the data will be the more consistent. So that's what I'm saying here. Okay, consistency over availability will be given importance over here. I think so I think from a this is a typical the way you looked into that vertical shardings when you are having that microservices architecture. This is one of the important thing from a database partitioning and database sharding. Here we have given the importance from database sharding and what are the practical steps, and this is what exactly needs to be followed whenever you're doing the database shardings in terms of vertical shardings. What are the practical steps? Number one is you need to dump the tables T1, then upload the table to the your target DB, then reuse, restore the dump to another DB, and then the replications. Look at the replications. It's almost completed. Then you do that cutover, rename that new table name in the new DB, then update those entry to the zookeepers. Or during all those things, when you're updating to the zookeeper, these are the manual activity, and then a few seconds there will be a TV not found. So yeah, so this is what in practical database sharding, vertical database sharding can happen. Yeah, of course, there is some advantages, disadvantages such as which I highlight, like it works for in a small and medium, even for a high tables also. But the moment there is a huge volume of tables, I think a replication is a important aspect, right? So that's where from a replication perspective it may an issue. So I think so you have to think about, right, how do you do in terms of vertical shading, one of the things to so I think that's all today from my side. Thank you very much. I'll come up with the other topics in my next video. Thank you everybody.